Okay, so we're going to go over optimization of volume and surface area. So, though this kind of impeded on the title here, we have what is considered golf netting. Okay, so if you were to be hitting golf balls indoors, you would need netting to ensure that it doesn't go flying and kill someone. So what you'll need for this is you'll need side netting, netting on top, and netting at the back. You won't need any netting on the floor, and you won't need any netting where you would walk in. Otherwise, you wouldn't be able to get in. Okay. So with these requirements, we want to minimize the amount of netting we're going to need to build this, and we want to make sure we have a volume of 144 meters cubed. Okay. So again, we're going to write down our formulas here. First of all, our volume formula in this case, and what they've told you is that the width and the height are going to be the same. It's the depth that will be different. Now, volume is width times height times depth, which can be written as x squared. Yeah, there we go. Problem solved. Okay, so this is our volume formula. And what we're going to be doing in this question is we're going to be trying to solve or set equal to a specific value. Okay, so we also know that our volume is 144 meters cubed, which means we can replace our volume with the value of 144 is equal to x squared y. Okay, so we have our volume in this question. We also want to know what our surface area is. Our surface area is technically 2x squared. That would give us the front and the back. And then because it's x times y 4 times around would be 4 by x y. But in this case, they said we don't need the front and we don't need the bottom. So we'll be subtracting 1 from both of these coefficients. So we'll have x squared plus 3xy as our surface area here. Okay? So what we're going to be doing in this question then is we're going to be taking our value and we want to be minimizing surface area. Okay? So we're going to set this equation equal to y. It'll be the simplest one to set it equal to, plus we'll only have to substitute for one value of y. So what we'll be doing here is we'll have y is equal to 144 over x squared. Okay? So that means we can now replace the y in the other equation with a value of x so that our surface area is only in terms of x. Once we have it in terms of something, we can derive it to find a specific value. So again, we'll be minimizing surface area. Surface area will be equal to x squared plus 3x times 144 x squared. I can simplify this part of the equation. Surface area is equal to x squared. 3 times 144 is going to give us 432, I think. 5? No. Okay. Over x squared. And then we can eliminate one of the x's. So we have surface area is equal to x squared plus 432x. Now that we've simplified our surface area question, we can go about deriving it. Okay? So we're going to find the derivative of this in order to minimize the amount we are going to need. So our surface area is equal to, surface area prime is equal to 2x. And in this case, I just want you guys to think of it as 432 to x and negative 1, which means subtract 2 and over x squared. Okay? So with this information now, remember whatever constant surface area was, we derived it is technically the value of 0. So we're going to solve for when it is equal to 0. That will give us a higher low point on this equation. It's when a rate of change is 0. So we move our 2x, 432 x squared. Move 2x to the other side, which will give us negative 2x is equal to negative 432 over x squared. Okay. I can multiply over, if I like, the x squared, which will give me 2x cubed is equal to negative 432, which means x cubed is equal to 432 divided by negative 2, which is, I think, 216. And we're going to be looking for the cubed root of both sides, which means x is 6 in this case. Okay? So, if x is 6 in this case, we can go back to our volume formula to find out what our y value is going to be. Okay? So our volume formula, which was equal to x squared y, volume was 144, and we've just discovered that our x is equal to the value of 6. 6 squared times y will give you 144 over 36 is equal to y. What is it? 4. So the dimensions that would minimize netting, a wonderful drawing here, will be 6 by 6 by 4.